Hello, space explorers, and welcome back to the Curiosity Club. I'm your host, and today we're launching into another episode of Secrets of Curiosity. Have you ever looked up at our one and only moon and wondered, why do some planets have so many? It's like they're collecting them. Well, get your space helmets on because we're about to uncover the cosmic secrets behind planetary moon collections. First off, let's talk about the titans of our solar system, Jupiter and Saturn. Jupiter, the biggest planet around, has a whopping 95 confirmed moons, and Saturn, famous for its incredible rings, isn't far behind with 146. Compare that to Earth's 1 or Mars's 2 tiny moons. So, what's the deal? Why are these gas giants so greedy when it comes to moons? The number one reason is gravity. Think of gravity as a planet's superpower. The bigger and heavier a planet is, the stronger its gravitational pull. Jupiter and Saturn are absolutely massive. Jupiter is so big that all the other planets in our solar system could fit inside it. This immense size gives them a gigantic gravitational field, like a cosmic fishing net cast wide across space. Now imagine our solar system when it was young, about 4.5 billion years ago. It was a chaotic place, full of swirling gas, dust, and countless chunks of rock and ice called planetesimals. These were the building blocks of planets. As the giant planets like Jupiter and Saturn formed, their powerful gravity started pulling in everything nearby. Some of this material clumped together to form the planets themselves, but a lot of it was captured into orbit around them. It's like a giant cosmic dance. An object flying through space would get too close to Jupiter, and instead of crashing into it or flying away, it would get caught by Jupiter's gravity and start circling it. And just like that, a new moon is born. This is called the capture theory, and scientists believe many of the smaller, irregularly shaped moons of Jupiter and Saturn were captured this way. They're basically space rocks that got trapped in orbit, but that's not the only way a planet gets a moon. There's another fascinating method that happened right around the giant planets themselves. When Jupiter and Saturn were forming, they were surrounded by huge disks of gas and dust, kind of like a mini solar system. Within these disks, materials started clumping together, just like the planets did around the sun. Little bits stuck together to make bigger bits, which then grew into the large, round moons we see today, like Jupiter's Galilean moons, Io, Europa, Ganymede, and Callisto, or Saturn's giant moon, Titan. These moons are often called regular moons because they formed right there with their parent planet and orbit in a neat, orderly fashion. So you have two main methods: capturing wandering space objects and forming moons from a disk of material right at home. The giant planets had the best of both worlds. Their massive gravity allowed them to capture lots of passers-by, and they were big enough to have their own moon-forming disks. Now let's zoom back in a bit. What about the inner planets, like Earth? Why don't we have dozens of moons? Well, for one, we're much smaller. Our gravitational pull isn't strong enough to capture passing asteroids as easily as Jupiter can. Plus, when the inner solar system was forming, it was hotter, and the powerful solar wind from the young sun blew away a lot of the leftover gas and dust. This meant there wasn't as much raw material available to form multiple moons around planets like Earth or Mars. But wait, we have a moon, and it's a pretty big one for a planet our size. So how did we get ours? The leading theory for our moon is really dramatic. It's called the giant impact hypothesis. The idea is that long ago, when Earth was just a baby planet, a Mars-sized object, which scientists nicknamed Theia, smashed right into it. This colossal collision sent a huge amount of molten rock and debris flying out into space. Over time, gravity pulled all that debris together, and it eventually formed our beautiful moon. So our moon is essentially a piece of Earth, born from a cosmic crash. This also helps explain why Mars only has two tiny moons, Phobos and Deimos. They are lumpy and potato-shaped, not round like our moon. Most astronomers think they are captured asteroids that strayed too close to Mars and got trapped by its gravity. They were so small that Mars' gravity was unstrong enough to pull them into a spherical shape. And what about Uranus and Neptune, the ice giants at the edge of our solar system? They also have a good number of moons. Neptune has 16, and Uranus has 28. Like Jupiter and Saturn, they're big enough to have captured some of their moons. Neptune's largest moon, Triton, is a great example. It actually orbits Neptune backward compared to the planet's rotation. This is a huge clue that Triton was likely a dwarf planet from the Kuiper belt, like Pluto, that got captured by Neptune's gravity. Uranus's moons are particularly strange. The planet is tilted completely on its side, and its moons orbit around its equator, meaning they go up and down like a Ferris wheel as they circle the planet. Scientists think a giant impact, similar to the one that formed our moon, might have knocked Uranus over long ago, and the debris from that collision formed its moons. So, to sum it up, the number of moons a planet has depends on a cosmic recipe with three main ingredients. First, the planet's size and mass, which determines its gravitational power. Bigger planets are better at collecting moons. Second, the planet's location in the solar system. The outer planets had more material to work with. And third, a planet's history. Did it have a giant impact? Was it able to capture wandering objects? Every planet's family of moons tells a unique story about its past. Jupiter and Saturn are like the bustling capitals of giant empires, with moons formed in-house and others captured from afar. Earth's moon is the child of a dramatic and violent birth. And the tiny moons of Mars are like adopted pets from the asteroid belt. It's amazing to think that by studying these distant moons, we can piece together the history of our entire solar system, a story written in the language of gravity and celestial mechanics over billions of years. The universe is full of these incredible secrets, just waiting for curious minds like ours to discover them. What's your favorite moon in the solar system? Let me know in the comments below. And if you enjoyed our deep dive into the cosmos, don't forget to hit that like button and subscribe to the Curiosity Club for more Secrets of Curiosity. Thanks for watching, and as always, stay curious.